We will wait for a few minutes more and then I will start at 7:10 or 15. So I will be waiting for a few minutes for students to join and then I will start. Hello everyone, a very good evening to all. Myself, Vivekananda Naik. I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. I welcome you all for this interaction session on the course Solid State Physics, which is being flowed this July 2024 session with course code NOC 24 PH43. This course is being flowed by NPTEL. So I will be taking the interaction sessions every week on Tuesday from 7 p.m. to 9 p.m. So this interaction session is mainly meant for solving a few sample problems that will be covering the current week's lecture, and this will help you to solve the assignment problems that are being given as a part of the course fulfillment. So in each week, I will be solving a few sample problems that will be based on the lectures of that week's lecture. So let's start with our today's session. So this week was mainly about the introduction to the course and introduction to the structure of atom and introduction to the solids. There are types of solids like mainly amorphous and crystalline. So the first question says the first question says out of which out of the following, which is the amorphous material? So we know, according to the arrangement of the atoms, metals are being classified into two types. One is crystalline, another is amorphous. In case of crystalline material, they are the atoms or the constituents of the material are arranged in a periodic manner. So as you can see in this figure, they are arranged periodically. So they are arranged periodically. But here, in case of amorphous, they are arranged randomly. So, since in case of crystalline material, the atoms and the molecules they repeat a certain pattern. Like if you see here, this is a pattern. So this is called as 2D hexagonal pattern. In the upcoming courses, you will be learning more about it. So in this crystalline material or crystalline in this crystalline material, the atoms are arranged in a periodical manner, due to which there are some specific characteristics of those atoms. However, in case of amorphous material, like if you see, there is no fixed periodicity or no fixed structure through which they are being arranged. So the two materials will differ in their physical and mainly in their chemical properties. Also, there are different properties that will affect those arrangement of the atoms. So the question says, out of the following, which is the amorphous material? So option A is lead, option B is brass, option C is glass, and option D is silver. So I'll give you a few minutes to think about it and then I will discuss. So if we talk about this problem, the question was out of the following, which is the amorphous material? And we know in case of amorphous material, they are arranged randomly. So if you see the options, option A is lead. And if you talk about lead, uh, lead is crystalline in nature, and the structure is FCC or face centered cubic. FCC, which is face centered cubic. So they belong to cubic crystals. Similarly, in case of brass also, and in case of silver also, all of them exhibit face-centered cubic, that is crystalline structure. However, in case of glass, glass is an amorphous solid, and in case of glass, we know glass is a mixture of silica, lime, and soda ash, out of which silica is the main constituent. And in case of glass, it is a non-crystalline amorphous and it is a transparent solid. So the correct option will be glass. Glass is amorphous in nature. So if you talk about crystalline and amorphous materials, in case of crystalline solids, they have a definite arrangements or definite internal atomic structure that follows or that are repeated with a certain pattern. So if you see in this case, in the left hand side, they have a certain repeating pattern. Arranged periodically means they have a repeating pattern. However, in case of amorphous, they are nearly opposite in most of the ways from crystalline solids. They have irregular internal atomic structures, and as a result, they don't they don't exhibit certain properties that are exhibited by the crystalline solids. I hope this is clear to all of you. Then we'll proceed to the next question. The question says the resistivities of semiconductors lie between the options are option A 10 to the power 6 and 10 to the power 10 ohm, 10 to the power minus 1 and 10 to the power 5 ohm, 10 to the power minus 5 and 10 to the power minus 2 ohm, or none of these. So I'll give you a few minutes to think about it and then I will discuss. So if we discuss about this question, the question is resistivities of semiconductors lie between, the options are option A 10 to the power 6 to 10 to the power 10 ohm, option B 10 to the power minus 1 and 10 to the power minus 5, 10 to the power minus 1 and 10 to the power 5 ohm, option C 10 to the power minus 5 and 10 to the power minus 2 ohm, and option D none of these. So we know resistivity and conductivity, they are related to the electrical or electric properties of the matter, and mainly the electric properties of the matter is determined by the electron transport in that particular material. So if we talk about the types of material, depending upon their electrical properties, the materials are classified into mainly three types. So depending upon the electrical property, matter is classified into three types. One is metal, or mainly not exactly metal. They can be classified as conductor, semiconductor, and insulator. So, as the name implies, it is obvious that conductors will be having higher electrical conductivity and insulators will be having higher resistivity. So, these conductivities and resistivity that depend upon the movement of electron inside that particular matter. We know there are three electrons or valence electrons that are responsible for electrical conduction. So if you talk about the conductivity and resistivity formula, resistivity which is given by rho, and the relation between resistivity and conductivity is given by rho is inverse proportional to 1 by sigma, where rho is the resistivity and sigma is conductivity. Now, if we talk about the resistivities of semiconductors, so in case of semiconductors, there are a very few electrons that are available to carry electric current. So they are better conductors in comparison to insulator. However, they are bad conductors in comparison to the conductor. So in case of semiconductor, if you talk about their behavior at absolute zero temperature. So at 0 Kelvin, semiconductor generally behave as insulator because there are no free electrons available to carry electricity. However, as the temperature rises, their conductivity increases or the resistivity decreases because there are, due to thermal agitation, there are a few electrons that will be available for electric or current conduction. So if you talk about the resistivity of semiconductor materials, they lie between 10 to the power minus 1 to 10 to the power 5 ohm. So 10 to the power minus 1 means very low, that is 0.1 ohm to 10 to the power 5 ohm. Now, if you talk about, so this is the correct option, the resistivity of the semiconductors. However, if you talk about insulators, insulators have very high resistivity, so they have the resistivities that rise from 10 to the power 6 to 10 to the power 10 ohm. And if you talk about conductors, they have very low conductivity, that is 10 to the power minus 5 to 10 to the power minus 2 ohm. So this is of conductors. So depending upon the electrical properties, materials are classified into mainly three types, and out of which the conductivity of conductor is highest, then comes semiconductor, and then insulator. So in case of resistivity, it is opposite. Resistivity is more for insulators, and then semiconductors, and then low resistivity is for conductors. So the correct option will be option B, that is 10 to the power minus 1 to 10 to the power 5 ohm. Then question 3, which structure can be studied by naked eye? Options are option A, atomic structure, option B, grain structure, option C, microstructure, and option D, macrostructure. So this is a bit straightforward question, you may say. because in order to study atomic structure, atom consists of electrons and nucleus, so you need powerful microscopes or electron microscopes. So mm, in naked eye, atomic structure can be studied. Similarly, grain structure and microstructures, they can be studied. However, in case of macrostructures, they are examined under low microscopes or even with naked eye. So these macrostructures can reveal flaws or any defects in the material, segregations, cracks, etc. by proper techniques. So the correct option will be option D, that is macrostructure. All these structures can be studied fully or up to greater extent with more clarity by naked eyes. However, macrostructures can be studied with naked eye, which reveals different. So what it reveals? It reveals any flaws or defects, then segregations, cracks, etc. So there are proper techniques through which by naked eye we can study different macrostructure that will reveal all these properties. I hope this is clear to all of you. Now continuing our discussion to the next question. The question says the total energy of a electron revolving in the nth orbit or shell of an atom is equals to, these are the options. Option A is minus mz square e4 divided by 8 epsilon 0 square n square h square. Option B minus m z square e square divided by 4 epsilon 0 square n square h square. Option C m z square e square divided by 2 epsilon 0 n square h square. And option D m z e square divided by epsilon 0 square n square h square. So I'll give you a few minutes to try this question, and after some time I will discuss. So this question is based on the structure of atom. The total energy of an electron revolving in the nth orbit of an atom is equal to. So uh, let us consider the Bohr's model for one electron atom. So in case of Bohr's model, what he had assumed, there is a nucleus which is present at the center. Suppose the nucleus is plus JD, because we know nucleus is positively charged, and there is an electron which is revolving around the nucleus. Suppose mass of the electron is small m, E is the charge of electron, Z is the atomic number or number of protons present in the nucleus, and H is Planck's constant. We all know epsilon 0 is the absolute permittivity of free space. Then, according to Bohr's theory, when the electron revolves surrounding the nucleus, the electrostatic force of interaction between the electron and the nucleus provides the necessary centripetal force, due to which there is circular motion of electron surrounding the nucleus. So we know the Coulomb's force, which is given by F is equal to K Q1 Q2 by R square. So here Q1 is electron, Q2 is uh, so there are two forces. One is centripetal force, another is Coulomb's force. These two forces are balanced, due to which there is circular motion of electrons around the nucleus. So we can say Coulomb's force is equals to centripetal force. And Coulomb force, we know Coulomb force is by K Q1 Q2 by R square equals to centripetal force is given by mv square by R. So here K, we know K is 1 by 4 pi epsilon 0. So 1 by 4 pi epsilon 0, and Q1 Q2, Q is E, Q2 is. So since we are balancing the two forces, we will take only the magnitude of the forces because they are opposite in direction, so that they are being balanced. So it will be E into JD divided by R square, where R is the radius of this orbit, which is equals to mv square by R. mv square by R. So if you talk about another assumptions of Bohr's model, Bohr's had said that electrons will be revolving in that orbits where the angular momentum electron is an integral multiple of h cross or h by 2 pi. So the angular moment of electron L is equal to mvr, which is equals to nh by 2 pi, where n is the principal quantum number. So if we compare these two equations, equation 1 and equation 2, then we can see the value of V. The value of V here will be nh divided by 2 pi mr. So if we put the value of V here, we will get simply we can directly write half mv square will be z square divided by 8 pi epsilon 0 r. So if you write here half mv square, this r will get cancelled out. It will be z square by 8 pi epsilon 0 r. So this is half mv square. So half mv square is nothing but the kinetic energy. Similarly, if we talk about the potential energy, the potential energy is nothing but the Coulombic force of interaction. So the potential energy, we know it will be Q1, Q2 by R, K Q1, Q2 by R. So U will be, potential energy will be Z square minus Z square divided by 4 pi epsilon 0 R. Or we can write it 1 by 4 pi epsilon 0 minus E into JD divided by R. So the question says the total energy of the electron. So the total energy will be kinetic energy plus potential energy. So kinetic energy is equal to Z square divided by 8 pi epsilon 0 R minus Z square divided by 4 pi epsilon 0 r. So it will be minus z square divided by 8 pi epsilon 0 r. So you can see the total energy negative, that is, it is an attractive system. So there is force of attraction between electron and the nucleus. However, if you see the options, these are in different form. So if you see the options clearly, here it is z square by 8 pi epsilon 0 r, but here there is no r present. So we need to put the value of r. So how we will calculate the value of r? If you compare these two equations, because it is mvr and another is mv square by r. So if you compare these two equations, you will get, so comparing 1 and 2, what we will get, r will be n square h square epsilon 0 by pi m z square. So if we put the value of r, then u will be, the total energy will be minus z square divided by 8 pi epsilon 0 r, which will be z square divided by 8 pi epsilon 0 into r. R is n square h square epsilon 0 by pi m z square. So total energy will be minus m z square e fourth divided by 8 n square h square epsilon 0 square. So this is the correct answer. And if you see the options, the option A, m z square e fourth divided by 8 epsilon 0 square n square s square is the correct option. That is option A. So the total energy of an electron revolving in the nth orbit of a cell is given by m z square e fourth by 8 epsilon 0 square n square s square, and the value is negative, which reflects that the electron is being attracted by the nucleus continuously, so the energy is negative. So this is a bound system, and for bound system the energy is negative always. So if we talk about this question again, so first we balanced the force, Coulombic force of interaction between the nucleus and the electron with the centripetal force, and after balancing, we got the expression for total energy. We got the expression for kinetic energy, which is half mv square, and then if you add potential energy to the kinetic energy, then it will give the total energy. However, the form of total energy contains r, but in options there are no r. So we compare the two equations, that is the force balance equation and the angular moment of quantization of angular momentum equation. So from this relation, we can get r is equals to n square s square epsilon 0 by pi m z square. And then if you put the value of r, you will get the total energy of the electron is given by minus m z square e 4 divided by 8 n square s square epsilon 0 square. I hope this is clear to everyone. Also, you can say that this energy, all these values are constant, so it will be inversely proportional to n square. That is the number of levels of the principal quantum number. So I hope this is clear to all of you. Then the fifth question, the direction of spin of an electron is given by principal quantum number H, azimuthal quantum number L, magnetic quantum number M, or spin quantum number S. So if we talk about the spin of the electrons, we know when the electrons are revolving surrounding a nucleus, there are different quantum numbers that are used to identify the level of electrons it is revolving, because surrounding the nucleus there are different energy levels. So corresponding to each energy levels there are different sub levels, and there are different motions of the electron. So like the electron is revolving around the nucleus in certain orbit, so corresponding to that particular orbit there is orbital quantum number or number. And then the when the atom is placed in an external magnetic field, then due to the motion of the electron, there is magnetic dipole moment of the electron, and since the moving electron surrounding the atom act as a magnetic dipole, so it will also experience force in presence of magnetic field. So due to it, there is magnetic quantum number also present, and due to the spin of the electron, there is spin quantum number because um, addition to the revolving of electrons around the nucleus, electron is also revolving surrounding itself, due to which we have spin, and this spin of the electron is determined by the spin quantum number s. So we can say that the direction of spin of an electron is given by the spin quantum number, which is option D. So option D is correct. And also we know for electron, the value of S is half, and for a particular value of S, we have 2s plus 1 ms values. So since S is equals to half, so we have 2 ms values, which are plus half and minus half. So plus half means spin up and minus half means spin down. So there are two different orientation of electrons. So the spin of electron, so there are two values of ms. What is ms? So whenever electron is placed in an external magnetic field, the motion of the electrons gets affected by the magnetic field, and there are two components of its dipole moment. So one is ms h cross, another is minus. So one is ms h cross. So corresponding to the value of ms, whether it is half or it is minus half, so depends upon whether the electron has up spin or down spin. So the spin quantum number s gives the direction of spin of the electron in an atom. And also, if you talk about Pauli's exclusion principle, according to Pauli's exclusion principle, no two electrons in an atom can have all the four quantum numbers equal. So these are four quantum numbers, mainly n, l, ml, and ms. So there are four quantum numbers. N is principal quantum number, l is azimuthal quantum number. This is orbital angular momentum quantum number. This is spin angular momentum quantum number. So since suppose this is a cell, but this is P. P means for P L equals to 1, so there will be three subcells corresponding to ML equals to -1, 0, and 1. So if there are two electrons present here, for both the electrons, ML is equal, that is -1. However, their MS values differ. So for one electron, MS will be half, and for other electron, MS will be -half. So no two electrons in an atom can have all the four quantum numbers equal. That is called as Pauli's exclusion principle. So this also signifies that maximum two electrons can be present in a subset. I hope it clears your doubts if you have any. Then coming to question 6, for a hydrogen atom, the total energy of an electron is minus 3.4 electron volt. Then the electron belongs to option A first orbit, option B second orbit, option C third orbit, or option D fourth orbit. So I will give you a few minutes to try this question, and then we will discuss how we will solve or how we will determine whether the electron belongs to first orbit or second, third, or fourth orbit, depending upon the energy value it has. So this question is So talking about the question was for a hydrogen atom, the total energy of an electron is minus 3.4 electron volt. The electron belongs to which orbit? So before a few questions, we just calculated the total energy of an electron in an nth orbit of the atom, and the expression was En is minus 1 by 8 m z square E4 by n square S square epsilon 0 square. So if you put all the values, then we will get, so putting the values, so m is the mass of electron, which is 9.1 into 10 to the power minus 31 kg. Z is 1 because it is for hydrogen. We are calculating the energy of electron for hydrogen atom. Then n we need to identify, because n will determine the electron will be belonging to which level. And then h is Planck's constant. It is 6.67 into 10 to the power minus 34 joule into second. Then epsilon naught, it is 8.854 into 10 to the power 9 Newton into meter square Coulomb square. Or if you put the value of 1, it is 10 to the minus 12, not 8.854 10 to the minus 12 Newton to meter square per Coulomb square. So if we put all these values, we will get for hydrogen, for hydrogen atom, the value of energy of the electron is given by minus 13.6 by n square in electron volt, where we have put 1 electron volt is 1.6 into 10 to the power minus 19 joule. So this is the conversion factor from electron volt to joule. So if we put the values, we will get the energy of electron in an hydrogen atom at the nth orbit is given by minus 13.6 by n square electron volt. So if we put the value of n equal to 1, then E1 at the ground state will be minus 13.6 divided by 1 square, which will be minus 13.6 electron volt. For n equal to 2, E2 is minus 13.6 divided by 2 square, so it will be minus 3.4 eV. So if we see the values in the question, the value is minus 3.4 electron volt. So minus 3.4 electron volt corresponding to E2 level, so which is second orbit. So the correct option will be option B, that is second orbit, because if the electron would have been present in the first orbit, the energy of the electron will be minus 13.6 electron volt. In case of second orbit, it will be minus 3.4 electron volt. So similarly, in case of third orbit, we can calculate it will be E3 minus 13.6 divided by 3 square, which is minus 13.6 by 9, that is roughly minus 1.51 electron volt. And similarly, for n equal to 4, E4 will be minus 13.6 divided by 16, which is minus 0.85 minus 0.85 electron volt. So it will be minus 1.51 electron volt minus 0.85 electron volt. So the correct option will be option B, and the electron having energy minus 3.4 electron volt belongs to second orbit of hydrogen atom. It is specifically for hydrogen atom because for hydrogen atom n equals to 1. Similarly, if you talk about helium, then Z will be 2. Then again, Z, since it is Z square, so minus 13.6 into 2 square. That is, there will be 4 times that of the energy. So the ground state energy of electron in helium is 4 times that of the ground state energy of hydrogen. Then continuing our discussion, question number 7. For a hydrogen atom, the binding energy of the electron in the nth orbit is option A 10.2 by n electron volt, option B 13.6 by n square electron volt, 13.6 by n electron volt, and option D none of these. So this is a good question. So I'll give you a few minutes to think about it, and after some time I will discuss. The question is, for a hydrogen atom, the binding energy of the electron in the nth orbit, what is the binding energy? So, first we need to understand what do we mean by the binding energy. So, we just discussed about the energy of the electrons in the in different levels of the hydrogen atom. Now, according to binding energy, the definition of the binding energy, it is the amount of energy required to remove the electron from that particular atom. So, if we are comparing the energies of the electron when it is present in the atom and when it is free from the atom, then free means the energy is zero. So, if you talk about these questions, so for n equal to 1, the energy is minus 13.6 electron volt. For n equal to 2, it is minus 3.4 electron volt. So if the atom is present at n equal to 1, and if you want it to be present at n equal to 2, then you need to give some energy so that it will move from 1 to 2. So similarly, the binding energy is defined as the energy of the electron that we need to supply to that electron so that it will be coming out of the atom. So the total energy of the electron after will be zero. So, so the electron will be free. Then free electron means energy is zero. So its final energy is zero. Now, if the electron is present in the nth orbit, what is the energy of that electron? We just discussed it is minus 13.6 by n square electron volt for nth orbit. So, what will the binding energy of electron? So, the binding energy of the electron will be E infinity minus En. So, this is nothing but E infinity. That is when it is very, very far away from the atom. So, the total energy for R equal to infinity, for R equal to infinity at a very large distance, the total energy of the electron will be zero. So, it will be E infinity minus En. So, it is 0 minus minus 13.6 divided by n square. So, it is plus 13.6 divided by n square electron volt. So, this is the binding energy. So, the binding energy of the electron in the hydrogen atom is given by option B 13.6 by n square electron volt. I hope this is clear to all of you. Then question number 8. When the orbital quantum number L equals to 3, the orbital magnetic quantum number ML takes the following number of values. The options are option A 6, option B 10, option C 7, and option D 14. So I'll give a few minutes to try this question, and after some time I will discuss. So now talking about the question. So for orbital contour number L equals to 3, we have 3L plus 1 number of ml values. So for L equal to 3, ml values will be 3L plus 1 value. So sorry, it will be 2L plus 1 values, not 3L. 2 into 3 plus 1. So 6 plus 1, that is 7 values. So for L equal to 3, there are 7 ml values. So what are they? Minus 3, minus 2, minus 1, 0, 1, 2, 3. So these are 7 values of ml. So what is ml? So suppose uh, suppose an electron is revolving in an orbit. So its angular momentum will be having 7 different projections corresponding to the z axis. Suppose the magnetic field is applied along z. This is z axis. Then corresponding to each z, there will be 7 projections of depending upon the value of ml. So there will be 1, 2, 3, 1, 2, 3 like this. So this is 1, 2, 3, 4, 5, 6, 7. So there will be 7 ml values or 7 possible orientations corresponding to particular value of L. Then question number 9. In a covalent bond, the element possesses strong attractive forces. B. One of the atom lends electron, the atom shares the electrons, or D. None of the above. So in case of a covalent bond, options are the element possesses strong attractive forces. One of the atom lends electron, the atom shares the electron, and none of the above. So if you talk about a covalent bond, when two atoms share their electrons and then covalent bond is formed. So the two atoms that are covalently bonded with each other contribute at least one electron to the bond, and it is shared, and the shared electron may be considered to be belonging to both the atoms. So the correct option will be option C. The atoms share the electron, but the option but if you talk about the option B, one of the electron lends electron, it is not possible because in case of covalent bond, the bond is formed as a result of sharing of electrons between the two constituent atoms. So the correct option will be option C. That is, the atom shares the electron. Then question 10. A primary bond is formed between the atoms, between the molecules, between the atoms and molecules, and D, none of the above. So I'll give a few minutes to think about this question and then I will discuss. So if you talk about types of bonding, there are two types of bonds. One is, so if you talk about bonding, there are two types of bonds. One is primary bond, another is secondary bond. So in case of primary bonds, they are also known as strong bonds or chemical bonds, and the bond takes place the main forces that holds the atoms together in the molecules. However, in case of secondary bonds, those are also known as weak bonds or intermolecular forces. They are relatively weaker, and that occurs between molecules or parts of the molecule. So primary bond mainly occurs between atoms. However, secondary bonds that occur between molecules or part of the molecules. And primary bonds are generally called as strong bonds, and secondary bonds are generally called as weak or intermolecular forces. And if you talk about the types of primary bonds, they are called as covalent bond, ionic bond, and metallic bond. However, in case of secondary bond, the examples of secondary bonds are van der Waals forces, hydrogen bond, and dipole-dipole interactions. So, if the question says a primary, according to the question, a primary bond is formed between the atoms, between the molecules, between the atoms and molecules, and option D, none of the above. So, the correct option will be between the atoms because primary bonds are formed between the atoms. However, secondary bonds are formed between the molecules because if you see whether it is an covalent bond, ionic bond, or metallic bond, these type of bonds are formed between two atoms. So the correct option will be option A, that is the primary bond is formed between the atoms. I hope this is clear to you. The question number 11. During the formation of a primary bond, option A, some energy is lost. Option B, some energy is gained. Option C, energy remains constant. Or option D, none of the above. So I will give a few minutes to think about this question and then I will discuss. So in the previous question, we just talked about the nature of primary bond. So in case of primary bond, it occurs between two, mainly between two atoms, and some of the examples are covalent bonds, ionic bonds, and metallic bonds. And if you see, in case of these bonds, the attractive forces in the primary bonds are directly associated with the valence electron. So, why an atom undergoes bonding? So, when it wants to become stable, that is stable means it wants to have a very low energy, because we know the lowest energy is always the most stable form, or the more stable condition. So, the outer shell electrons are which are called as valence electrons. These outer shell electrons contains some valence electrons, and they are at high energy state, and they are relatively unstable. So if it can act, so for a valence electron, if it can acquire more electrons to bring the total number of electrons to 8 electrons, or it wants to lose electrons, so it can become more stable. So this is how atomic bonds or primary bonds are generally formed. In fact, in a so So if you talk about the primary bonding, in case of primary bonding, it is a direct consequences of exchange or sharing of the electrons. So when there is exchange of electrons, it is called as ionic bonding, and if there is sharing of electrons, it is called as covalent bonding or metallic bonding. So we can say that in case of primary bond, there is a lowering of energy, and due to which the bond is formed. So in case of primary bonding, we can say that some energy is lost. So the atoms becomes more stable, and since some energy is lost, in order to break that atom or break that bond, we need to supply additional energy. So they are mainly more strong as compared to secondary bonds. So the correct option will be option A, that is some energy is lost. Then question number 12, the solid phase of an element follows van der Waals bonding with interatomic potential given by Vr equals to minus P by at to the power 6 plus Q by at to the power 12, where P and Q are constant. Find out the equilibrium spacing or the bond length when the potential energy is minimum. So if you see this question, find out the equilibrium spacing or the bond length when the potential energy is minimum. So in case of primary bonding, normally there is minimum energy, or in case of any type of bonding, the consistence of the atom or the electrons, they tend to have lower energy. So in order to achieve those lower energy, they either want to lose their electrons or share their electrons, so that they will be having a lower energy. So in the process of making a bond, some amount of energy is lost, and due to which there is lowering of energies in case of primary bonding. So if you come to this question, the question says the solid phase of an element follows van der Waals bonding with interatomic potential, which is given by Vr equals minus P by at to the power 6 plus Q by at to the power 12, where P and Q are constant. Find out the equilibrium spacing or bond length when potential energy is the minimum. The options are 2Q by P to the power 1 by 6, Q by P to the power minus 6, P by 2Q to the power 6, and P by Q to the power minus 6. So these are the four options. I'll give you a few minutes to try this question, and then I will discuss. So if we talk about the interatomic potential is given by VR equals to minus P by r to the power 6 plus Q by r to the power 12. So this is repulsive term and this is attractive term. So at larger distance they are repulsive in nature, but at smaller distance they are, well, at very smaller distance they are repulsive in nature, but at larger distance they are attractive in nature. So the question says find out the equilibrium spacing on bond length when the potential energy is minimum. So for minimum potential energy, here the variable is R. So for minimum potential energy, the potential is minimum. So for minimum potential at R equals to R0, that is equilibrium spacing, VR equals to V R0, which is minimum. That implies del B by del R at R equals to R0 is equals to 0. So if you take the derivative, then dB by dr will be 6p by r to the power 7 plus, sorry, minus 12q by r to the power 13. So 6p by r to the power 7 minus 12q by, if you put it r in place of r, if you put r0, then it will be 0. Then 6p by r0 to the power 7 equals to 12q by r0 to the power 13. Then r0 to the power 6 is equals to, sorry, 12q by 6p. That implies r0 is 2q by p to the power 1 by 6. So this is the value of equilibrium distance at which the potential energy is minimum. So according to the question, find out the equilibrium spacing or the bond length where the potential energy is minimum. So the bond length or the equilibrium distance will be 2q by p to the power 1 by 6. So the correct option will be 2q by p to the power 1 by 6. That is option A. So at that particular distance, the potential energy is minimum. So this equilibrium distance or equilibrium spacing is otherwise called as bond length also. So I hope this is clear to you. What we did basically, we just took the derivative of potential energy with respect to R, and for minimum potential energy the derivative is 0. So that's why the equilibrium distance can be calculated and the value is 2q by p to the power 1 by 6. And going to question number 13, which is the last question of today's interaction session. The question says the interaction energy of two particles in the electrostatic field of each other is given by UR equals to minus A by R plus B by R to the power 9. Then find out potential energy when particles form a stable compound. Consider the equilibrium spacing of the stable compound is at 0. So this question is pretty much similar to the previous question. In the previous question, there was the equilibrium distance. Now here we need to find out the energy at that equilibrium distance. So I will give you a few minutes to try this question, and then after some time I will discuss. So in the previous question, we only calculated the equilibrium spacing, but here we will calculate the energy at that equilibrium spacing. So we have U R equals to minus A by R plus B by R to the power 9. So for equilibrium spacing R0, at R equals to R0, du by dr equals to 0. That implies A by R square minus 9B by R to the power 10 equals to 0. That implies A by R square equals to 9B by R to the power 10. That implies R to the power 8 or R0 to the power 8 equals to 9B by A, or R0 equals to 9B by A to the power 1 by 8. So this is the value of R, sorry, this is the value of the equilibrium distance. Now calculating the uh, potential energy at that distance, the potential energy U at 0 equals to minus A by R0 plus B by R0 to the power 9. So minus A by R0 is nothing but 9B by A to the power 1 by 8 plus B by 9B by 8 to the power 9 by 8. That implies minus A to the power minus 1 by 8. So it will be minus A by R0 So if we write it, we can write this is 9B by A to the power 1 by 8. This is B by, so this is A by 9B by A to the power 1 by 8 plus B by 9B by A into 9B by A to the power 1 by 8. So this is, if you take 1 by 9B by A to the power 1 by 8, it will be minus A plus AB by AB. Sorry, 1 minute. I did something wrong. This will not be, this is 9. So we need to do it again once again. So this is minus A divided by 9B by A to the power 1 by 8 plus B divided by 9B by A into 9B by A to the power 1 by 8. If you take 1 by 9B by A to the power 1 by 8 common, it will be minus A plus A by AB by 9B. So BB gets cancelled out. It will be, we know this is nothing but R0. So this is, if you see, this is 9b by 8 to the power 1 by 8 is nothing but R0. 9b by 8 to the power 1 by 8. So it is 1 by R0 minus A plus, or if you take A outside into A, this is 1 by 9 minus 1. It will be A by R0 into minus 8 by 9. So the energy at R0 will be minus 8A by 9 R0 energy units. So the correct option will be minus 8 by 9 A by R0 energy units. That is option C is correct. So in the previous question, we had calculated the equilibrium distance. However, in this question, we went a step further. We calculated the value of the energy at that equilibrium distance. So first we calculated the equilibrium distance for minimum potential energy at that equilibrium distance. The derivative of potential energy with respect to R is 0. So equating those, we get 9b by a to the power 1 by 8, which is the value of equilibrium distance. And if you put the value of equilibrium distance at those points, you will get the value of potential energy as minus 8A divided by 9 at 0 units. So the correct option will be option C. I hope this is clear to all of you. So with this, I come to the end of today's interaction session. So in today's interaction session, I discussed about a few problems that was based on week 1 of the lectures of solid state physics. This covered types of bonding, some elementary problems related to atomic structure, and types of solids, that is amorphous or crystalline solid, and their properties. So in the upcoming weeks, I will be solving a few more problems, which will be based on the week's lecture, and I'll be hoping for more students to join in the interaction session so that we can discuss any doubts or any concerns that you may be having related to the course. With this, I come to the end of the today's interaction session. I will thank you all again for participating in this course, and I will try my best to clarify all the doubts that we will be having throughout this course. That's it from my side. Have a good day.